Yes, let us start our science class. Yes, in previous class we discussed about the structure of atom. That is a new chapter we started, and we discussed some of the concept. In that we come to know that in olden days everyone believed Dalton's theory. Okay, after that what happened? What is his theory? What he is saying? Yeah, atoms are very, very small. Further divisions we can't do in a single atom. That is, it is indivisible, he is saying. Later what happened? We come to know that there is a subatomic particles are present inside the atom. So we can divide atom into small particles, some small parts like subatomic particles like protons, neutrons and electrons. So what happened? His theory is failed. Next, what happened after that? New models came for the structure, and first J.J. Thomson, what he is saying? Thomson is saying that atom is very much similar to the watermelon or else Christmas pudding, plum pudding. Many names he is giving. So what he is saying in that? Positive charges are as a spear. It is how the flesh in the watermelon. Upon that, electrons like a seed, how they are embedded in that flesh. Same as that, he is comparing the watermelon structure, and he is saying that same as that there is a presence of protons and electrons and how the arrangement. According to him, that is just theory, it is not at all a practical. So yesterday we said that if it is a practically, if they are proving, means we can believe that one. Otherwise, as a science students, we are not believing any blind beliefs or any stories, because we have to see that one in our naked eye, or else the proof we have to see. Okay, because of we know that the meaning of science is the study of truth. Okay, science itself, it means a study of truth. So what happened? His theory is failed because it has some drawbacks. What are the drawbacks of Thomson model? Is he could not explain anything about the nucleus. Only he is explaining about atoms in an atom, how the electrons and protons are arranged. Okay, so he failed to explain the stability of an atom. Upon that, he failed to explain the structure or else the nucleus, presence of nucleus in the atom. Upon that, he got one more credit. The discovery of electron is who discovered the electrons? Yes, J.J. Thomson. Yes. Later what happened? Because of his failure, his theory is failed. So what happened? One more scientist named Ernest Rutherford. Okay, what he is doing? He is giving a new idea towards the structure of an atom. Okay, in today's class we are going to study about the Rutherford's model of an atom. So write down the heading: Rutherford's model of an atom. Rutherford's model of an atom. Main intention what he had that time to discover, that is a nucleus. What Thomson is not explained, that is about nucleus, only two subatomic particles he explained, right? So what happened? Ernest Rutherford, actually he is a very famous scientist, one of the very famous scientists in nuclear physics, and he got a Nobel Prize, and he is one of the great chemistry scientists. He is Rutherford. So he had number of in radioactivity and all, he had a number of achievements. Okay, so he got prizes such as the Nobel Prize, etc. Upon that, he is called as a father of nuclear physics. Okay, he is a father of nuclear physics. Yes. Now we'll see what his experiment. Okay, Ernest Rutherford was interested in knowing how the electrons are arranged in an atom. Already J.J. Thomson explained how it is they are embodied in the positive sphere. Electrons are embodied in the positive sphere. So his interest towards knowing how the electrons are arranged within the atom. Okay. So what he is doing, actually his intention was that one, how the electrons are arranged in an atom. Okay, so he is taking conducting an experiment, and finally he got the conclusion. We'll see what is that experiment, what he is doing in his experiment. What is his intention? Is to know the arrangement of electrons within an atom. Okay, exact position where it is present. So he is selecting a fast moving alpha particles. Okay, fast moving, it is alpha particles. See, we can write like this, alpha particles. That is the materials required for his experiment, alpha particles, and he is selecting a gold foil. Gold foil. It is very much similar to the silver foil what we are using to wrap the food materials in bakeries and all, in hotels, restaurant. Same as that, it is a gold foil. Gold foil means how it is. Now one more thing here, why he is choosing gold foil for his experiment? Okay, why he is saying, instead of that he could have take any other metals like iron or anything, but why he is preferring this gold? Because we know that gold has one more important character, that is what? That is a malleability character. What it means? We have studied in our lower class, malleability means we can beat it into small sheet like a paper. How the papers are there, see how thin it is. Same as that, very small layers, or else very small thin layers of gold, because it has a malleability property. So they can prepare how? Very small, as much as possible. Okay, small. Okay, what he done? Fast moving alpha particles were made to fall on this gold foil. Come to know, I will explain how it is. Okay, and small idea what and all the materials required for his. Okay, next, why he is taking gold foil? Is because he wanted a thin layers as possible. Here the size, okay, the thickness of this is almost 1000 atoms. Just imagine how much it will be then. What is the thickness of this gold foil? It's very small. You can see how this gold foil is. See, this is a gold foil like a aluminium foil. Okay, yes. Next, you will think that it is very costly, but still he used that because its experiment is how to success. Yes. Next, we will see what is this alpha particles. Okay, two things. Come to know why he choose this one. Upon that, alpha particles, why he is taking this alpha particles. Upon that, what is that alpha particles? Do you know any idea what is that alpha particles? See, alpha particles means actually it is very much similar to the helium. Like this, it is helium. What is the atomic number of helium? Is 2. We know what is the mass of this helium? Is 4. Now how much you can say here? What about the electrons here? 2 electrons, 2 protons and 2 neutrons. So we got the mass number here 4. Upon that, atomic number, that is the number of protons. But what is this? What is the difference between these helium atom and this alpha particle? Means here they are removing the electrons. Electrons are not there in this helium atom. So how it will be? Is we can see like this. See, 2 plus it is. They are removed 2 electrons. Now tell me, what is the charge of this helium, or else helium 2 plus ion, or else alpha particles? That is, yes, it has 2 plus charge. Now tell me, what is the proton number and neutron number? 2 proton and 2 neutrons, same as this helium, but electrons are not there. Okay, come to know. But these have a considerable amount of energy. Okay, it is having energy. So come to know now what is the difference between alpha particles and helium. Upon that, what is alpha particles? We can say that is nothing but 2 plus helium 2 plus ion. That is alpha particles are doubly charged helium ion. Note down, alpha particles are doubly charged helium ion, that is He2 plus. Yes, now we'll see what he is going to expect from this, not accept, expect from this. What he is thinking and what is the result he is getting. Okay, what and all he chose? Alpha particles, and so he need any source of this one, any that is like a gun it is, see, alpha gun it is. Okay, gun of alpha particles he is choosing, that is emitting the alpha particles upon that gold foil. Yes, yes. Next, it was expected that alpha particles would be deflected by the subatomic particles in the gold atom. What he is expecting? He is expecting that alpha particle, it is having the 2 plus charge, that is a positive ion it is, would be deflected by the subatomic particles in the gold atom. Actually, he is expecting like that. We will see what happened later. Okay? Yes. Before that, we have to know the experimental setup, how he is taken. Okay? Yes, we will see what he is taking here. He is taking a gold foil here. Upon that, a source for the alpha particles here, gun of alpha particle, gun of alpha particle. Okay, gun of alpha particles. Okay, it is going to continuously, it is emitting the alpha, but this setup how he is doing in dark region. Okay, I will say why he is doing in dark. Okay, it should be a dark region or a dark place. Now what happened? He is going to pass these alpha particles towards a gold foil. Here one more screen he have setted for the detection. Okay, what happens to the alpha particles when it strikes to this one? To detect, a screen he is placed over here. Now what happened? There is a starting of emission. See, emission starts. It is coming like this, alpha particle. It is alpha particles here. What happened? It is going to strike to this. Okay, and actually he is expecting what? It deflected by the subatomic particle. Okay, deflected by the subatomic particle. You know what is deflection? Yes, now we will see what is the observation he is observing in this. Okay, this is a simple experimental setup. Come to know now how it is, why he is using the screen, because to detect the this one, whether it is if it is here glowing means he can detect it comes like this, or else if it is glowing here he can say that it is passed through this one and it is shining over here. Okay, now the observation he observed in this is completely different. We'll see what are the observations. So write down the heading, student. Observation of Rutherford's model of an atom. Very, very important this is. They will ask for your exam. What is the observation? Okay. Here, most of the fast moving alpha particles passed straight through the gold foil. Means what? How it is? Most of the fast moving alpha particles comes like this and it is, see, blinking over here, shining over here. What it is? Most of the fast moving alpha particle passed straight through the gold foil. Okay, gold foil. Next, one more observation. Some of the alpha particle deflected by the foil by small angle. What happens? Some of the alpha particles are deflected. What it deflecting means? Yes, it is. I will draw like this and I will show here. See, this is a gold foil. There is atoms are present inside the gold foil. Okay. Yes. This is the atoms. What happened? Gun of alpha particles comes like this, and some of the alpha particles moving or is passing straightly through the gold foil, okay, without any deflection. In some case, what happened? Some of the alpha particles comes like this or else comes like this, and it is deflecting in small angle, or else it is coming like this and deflecting in small angle. Okay? So one more observation he got, very much surprising it is. Surprisingly, 1 out of every 12,000 particles appears to be rebounded. Means what? Surprisingly, he got the observation. Here what happened? They are rebounding. Means what it is? They are rebounding like this. They are coming in that same line, they are going back. Some are like this 190 degree, some are deflecting in small angle, some are going back in that same angle or a same line. Okay? Now, what are the three observations? What are the three observations he got? Most of the fast moving alpha particle pass straight through the gold foil. In second observation, first observation, second one what? Some alpha particles are deflected by the foil by small angle. Third one what? Surprisingly, some are rebounding. Almost surprisingly, 1 out of every 12,000 particles appears to be rebounded. So what he is saying, he is very surprised. Actually, he wanted to know the arrangement of electrons in an atom, but he is getting something else observation. So he is saying this result was almost an incredible as if you fire a 15-inch shell at a piece of tissue paper and it comes back and hits you. He is saying like that. Okay? Now, after the observation, we have to conclude something. So, what he is concluding? He is concluding that, write down the conclusion students, very, very important it is. Observation already we have discussed, we have written. Conclusion, most of the space inside the atom is empty because most of the alpha particle pass through the gold foil without getting deflected. So what he is saying, because of the without any deflection, most of the space inside the atom is empty. Because of the empty space, it is not deflecting, it is going straight through the gold foil. Okay? And for the second observation, he is concluding that very few particles were deflected from their path. Yes? Very few particles were deflected from their path, right? It indicates that the positive charge of the atom occupy in very little space. What he is saying? Few particles were deflected from their path. It indicates that positive charges of the atom occupies in very small in space. So because of that positive charge, it is deflected in small angle. So one more conclusion, how to give for the third observation, what is that? Yes, very small fractions of alpha particles were deflected by 180 degree. It indicates that all the positive charge and masses of the gold atom were concentrated in the very small volume within the atom. Okay? Yes. Now, he put forward the nuclear model of an atom. Unexpectedly, actually he wanted to find or study about the arrangement of electrons, right? Unexpectedly, what happened? He became the father of nucleus, or else he discovered the nucleus in an atom. Because in this experiment, unexpectedly he got the one of the subatomic particle, that is a nucleus inside, not particle, it is a new it is not subatomic particle. See, he come to know that there is a presence of nucleus in the atom. Okay, but we'll compare the size of these atoms and nucleus, how it is very, very small. If you are going to say in the radius form, radius of the nucleus is about 10 to the power 5 times less than the radius of an atom. So it is very small compared to the atom. Okay, atoms radius is bigger or else more or else large while comparing the radius of the nucleus. Come to know, student? Yes. So he put forward the nuclear model of an atom. Till now, no scientists were having the idea of nucleus, the presence of nucleus in an atom, but the great scientist, that is a Rutherford's model, saying that there is a presence of nucleus at the center of an atom. Okay, so he put forward the nuclear model of an atom. This experiment is also called as Rutherford's alpha particle scattering experiment. In exam they will ask to draw and explain the Rutherford alpha particle scattering experiment. Okay, now we come to know that what are the observation he got, upon that in what way, how he is going to conclude. Next we will see the features of this Rutherford's model. Okay, here first feature you have to write, student, along with me. I will say you, along with me you have to write. Here the first feature of this, we can predict the feature after studying the observation and conclusion. Yes, first feature is positive charged center in an atom is called as the nucleus. Yes, we come to know that after his conclusion, we come to know that nucleus is a positive charged center part of an atom. So it should be in the center. Upon that, nucleus is having the positive charge. Okay, so who is coiling first time the name nucleus? Yes. Next, nearly all the masses of an atom resides in the nucleus. So we come to know that most of the masses are present inside the nucleus. And second feature is the electrons. Actually he wanted to find out where the electrons are present in an atom. Unexpectedly he is getting something else and he became one more scientist for the discovery of nucleus. Yes. Now he is giving the exact positions of electrons. He is saying that electrons revolves around the nucleus in a circular path. If it is an atom or as if it is a nucleus, electrons are revolving around the nucleus in a circular path. So it is not stationary, it is mobile or else it is continuously moving. Yes, after studying his model we come to know that it is not, it is moving one. Electrons are revolving around the nucleus in a circular path. Next, he is saying about the size. Third feature is saying the size of the nucleus. Already we come to know that he is observed in his observation, size of the nucleus is very small while compared to the size of an atom. How many times more? Yes, radius of the nucleus is about 10 to the power 5 times less than the radius of an atom. Yes, these are about the features. So we studied observation, experimental setup, and first we studied the experimental setup, observation, conclusion and features. But it is not at all a final, students. There are some drawbacks for this Rutherford's model of an atom. Still there are a number of drawbacks. What he said, electrons are revolving around the nucleus. But what happened? He explained that the electrons in an atom revolves around the nucleus in well-definite orbits. Orbits means in a circular path. So, particles in circular orbit would experience acceleration. We know that while moving there will be a, yes, we know in physics we studied what is acceleration, all those things. Once again I am not going to remind you students, just find out the definition or else just check the definition for this acceleration. So what happened? Now electrons are experiencing the acceleration. Thus the revolving electrons would lose energy and finally what? Finally fall into the nucleus. These revolving electrons, because of that acceleration and all, what happened? It is falling into nucleus according to the Rutherford. Then how it will be that atom? The electrons are falling continuously, it is revolving and it is falling. We can't see the stability over here. But upon that what? We can't predict where the electrons are. Okay, the positions also we can't predict. But this cannot take place as an atom would be unstable and matter would not exist in the form we know. Already we know that always the atom is a neutral and stabilities according to Rutherford. By his idea we can say that it is unstable. He is saying that, we come to know that according to his idea it is not stable. But these are the small drawbacks. Later some scientists come forward and they are overcoming these drawbacks, and in present we come to know that exact structure of atoms. Okay, that we will study in next class. So just will recall what we have studied in today's class. Yes, in previous class we studied about the Thomson model of an atom. Just we continued second model, that is the Rutherford models of an atom. Actually he wanted to know the arrangement of electrons in an atom. Unexpectedly he is getting something else result. So that is a very good merit, or else that is a merit of his. Unknowingly he is getting something else result. How happy he may be that time? Yes. So he became the father of nuclear physics. Upon that he got a Nobel Prize for these great achievements in the chemistry. Okay. Now what happened? Experimental setup we studied. That experiment is called as Rutherford's alpha particle scattering experiment. Very famous experiment in the chemistry it is. Upon that it have the very good intention. Upon that it gave the great result to us. Okay, so we have to believe in his experiment, and we got in nucleus are presence at the center of the atom. And his observation is very, very important. In exam they will ask conclusion, what the conclusion he is getting. Upon that, what are the features of his experiment. Upon that last finally there are some drawbacks because of, according to his model, he is saying that, he is not saying, it is explaining us that atom is unstable. So that is completely wrong. So we will study next model in next class. So we try down today's questions. Explain the experimental setup of a Rutherford's model of an atom. Yes. Second question. What are the observations of Rutherford's model of an atom? Yes. Write down the features or else conclusion. Both they will ask in exam. Write down the features of Rutherford model of an atom and what are the conclusion of Rutherford's model of an atom. Finally, write down the merits of or else demerits or else drawbacks of Rutherford's model of an atom. Okay, thank you students.